All right, guys, let's start day 131 from math. All right, so let's get this into view. The first thing I want you to do is write your first name and your last name. Make sure you circle your homeroom. To start for today's math, we're going to do a PDN. So right now, I want you guys to press pause. Welcome back. Today for our PDN, we had to name each figure. Now, this is an assignment that we've done before in the past, so this is just a review to help you guys remember for when we return to school. All right, so we have a line that has a point on each end. Now, when we have a line that has a point on each end, we know that that is called a line segment. Make sure you're putting forth effort to try to spell these words correctly, and that you're taking your time and you're doing things the KIPP way. Now for number 2, we have a line that has an arrow on each end. Now we know if there's an arrow on each end, that means that it's going on forever in both directions, and that is called a line. And the final figure that we have is a dot. What is that called? It is called a point. We call this a point when we're doing geometry. So make sure you guys are remembering the language that we use and that you're using it when we're talking about the subject. Question number 4. Is this a line or a line segment? Now, if we scroll back up and we look at what a line segment looks like and what a line looks like, what can we describe this as? Now, I see a point, a point, a point, a point, and a point. I don't see any arrows, so I know that this is a line segment. So I'm just going to take my time and type out that I know this is a line segment because it has 2 end points. Throughout the entire line, there are 2 end points. So we can have line segment DE, we can have line segment EF, we can have line segment FG, we can have line segment FH. So either of these ending points can give us a line segment. Let's flip the page. Now, today's topic, we are going to be talking about rays. I've already taken the time to fill in the underlined portion for you, and we know that a ray is a part of a line that has 1 endpoint, and it extends in one direction forever. Now, mathematicians refer to a ray, or should I say a ray's beginning with its end point. So, in our chart, we're going to say it, draw it, and write it. Now, if we were saying ray DF, we would say it just that way, ray DF. Now, if we were going to draw it, we would draw it just like this. All right, so we have the point as D because we're starting with the end point, and the forever goes on and it is F. Now, if we're going to write it, we would write capital D, capital F, and we would have a very tiny small DF. So let's see if I can figure out how to do this, guys. Please work with me. This is a work in progress. Trying to get all of this stuff together. So we would have it right over the top, and it would be displayed as line DF when we write it. All right, so let's go on to the second one. When we're moving along to the second one, we would say ray X, Y. So we'd start at the ending point with X. Move that over a little bit, make it a capital X. And then we're going to go right here and we're going to say Y. It'll probably be somewhere right here, capital Y. Now let's go ahead and put this in there and move it around. So now we have ray X, Y. I'm getting kind of good at this, y'all. Okay, so if we were to write it, we would write capital X, capital Y, and then we would put one of these tiny little ray symbols. Let's scoot it over towards the middle, right about here. So it would look like this, ray X, Y. Now you can go on to do the next one on your own. I'll give you a few seconds to do so. All right, we have a challenge. Terrence said that the following geometric shape is a ray. Do you agree with him? Let's look at the characteristics. There is a line that has a point on one end and a point on the other. So do we agree with Terrence? Let's figure this out. I know that a line segment has an end point on each end. This kind of looks like that. So I'm going to write, I do not agree with Terrence because it is a line segment. We know that a ray has one ending point and one end that goes on forever. Let's look at our next topic, angles. Now, an angle, let's get this in, is a shape It is a fraction or a part of a circle. In order to create an angle, we will need two rays that share the same point. Now, the shared endpoint is called the vertex. Now, if we take the time and look at the diagram below, this shows us exactly what a ray looks like. Now, when we're looking at this figure, we see an endpoint and a forever, an endpoint and a forever. So we know that this is a ray because our endpoint is called the vertex. Let's keep it moving. All right, we say an angle's name by first reading one end of the ray, then the vertex, and then the other end of the ray. So if I were to look at this angle that we have right here, I'd say that this is angle ABC. Let's move on to types of angles. Now, angles are given special names depending on their measure. All right. Now, what do I mean by depending upon their measure? When we are creating angles, we measure them in degrees. A right angle has a square angle. So what do I mean by that? If we take a look right here, we can see that there's a square in the inside of the angle. Now that's an indicator that you're looking at a right angle. When measured using a protractor, it would measure 90 degrees. An acute angle is an angle that is smaller than a right angle. When measured using a protractor, it would measure less than 90 degrees. Take a look at the example. They're gauging us with a 90-degree angle. This angle that's in green would definitely be an acute angle because it is smaller than a 90-degree angle. An obtuse angle is an angle that is larger than a right angle. When measured using a protractor, it would measure more than a 90-degree angle. So again, they're giving us a gauge to see what a 90-degree angle looks like in blue, and then the green angle is considered obtuse. It's much bigger than the 90-degree angle. Now the last angle that we're working with is called a straight angle. And it is an angle that is flat or straight. When measured using a protractor, it would measure exactly 180 degrees. Let's move on to our examples. Example number 1 says, identify the type of angles below as acute, right, obtuse, or straight. Then identify the rays and vertex that make up the angles below. So I'm going to work on the first one with you in real time. So right here we have what type of angle. So we're going to look at the characteristics. I have a vertex and I have two lines that go on forever. Now, if I look at this and I see the square measure in the inside, I would definitely say that this is a right angle. Now let's go on. We have angle PQR. The first ray would be QP, and the second ray would be QR. The vertex would definitely be Q. Now for the sake of time, I went ahead and did the other two angles offline, but I do want you to take a moment to press pause and look at each option. The first angle is a right angle, the second is an obtuse angle, and the third is an acute angle. Press pause now. Okay, welcome back, guys. So we have the type, the angle, ray 1, ray 2, and the vertex for all three angles. Now is the time for independent practice. So I do want you to do example number 3 on your own. It says draw and label an obtuse angle as X, Y, Z. Now, after that, they want you to draw the vertex. The vertex is always in the middle of the angle. Then they want you to draw the first ray of the vertex and finally draw the second ray of the vertex. Remember, it's an obtuse angle, so it will be larger than a right angle and it will have two rays connecting at a vertex. From the examples that I showed you earlier today in the video, you should be able to do this on your own. I know you can do it. See you guys tomorrow.